fourDscape-based solution for command and control brings together multimedia real-time information sources and creates a realistic virtual scene, presenting all relevant data geo-registered in an interactive four-dimensional browser. Here at the Reagan Building Convention Center in Washington, D.C. is a live interactive recording of fourDscape technology in action. High-resolution aerial imagery, including 3D building models, create a realistic scene for a common operating picture under full user control. Live real-time sensor data is geo-registered within the scene to create a live view of a building campus or even full cities, managing large amounts of sensor data including live camera feeds. Drilling down into the building interior provides detailed floor plans and interior camera views, while maintaining the exterior context of surrounding buildings and exterior surveillance systems. Virtual status lights on exterior and interior building entrances and exits, plus all building mechanical systems, can provide a geo-registered link to all building systems. Multiple interior camera feeds can also be embedded within the floor plans, putting live video together within its surrounding context. The fourDscape browser enables automated situational awareness for human interaction, analysis, and response by integrating geospatial data with real-time sensor feeds into a single interactive virtual scene or common operating picture. All the user does is use the mouse in a fourDscape browser to fly into and look at the current area of interest. The automated situation awareness system does the rest by automatically presenting geolocated views, status, and controls to effectively analyze and manage many correlated datasets. fourDscape technology visually integrates a real-time interactive common operating picture. The area of interest can range anywhere from the whole Earth to a local campus or building. The system can auto-zoom into received alarms or sensor locations embedded and geo-registered in the visual scene. In this live recording of a fourDscape portal, an alarm was received at a local high school campus, and the common operating picture automatically zoomed to the alarm location, providing an immediate view of the local sensor information. In this example, local surveillance cameras show traffic conditions that help route the first responders around traffic jams towards a clear roadway to the high school campus. GPS-enabled AVL sensors can provide automated vehicle location data for the emergency vehicles, tracked by the fourDscape browser dynamically within the virtual scene. High-resolution aerial imagery and 3D campus building models produced directly from aerial imagery create a realistic virtual scene for an interactive command and control environment. This process is currently being used to build entire city models for real-time interactive visualizations using fourDscape technology, like the one previously shown for Washington, D.C. With the GPS-tracked emergency vehicles arriving on the scene, 3D floor plans can be injected into the scene, replacing the exterior building model and providing a geo-registered view of the building interiors. These 3D floor models are extruded directly from available CAD drawings. The fourDscape geo-tracking engine can be utilized to visually track many objects in 3D space and time, and record them for future playback and analysis. Objects being tracked over time could be GPS devices, RFID badges, wearable indoor tracking devices, or even geolocated alarms, alerts, or messages. In this example, utilizing real-time location data reports from wearable indoor tracking devices, emergency responders could be located and tracked visually within the 3D floor plans of the building. This visual tracking capability is also very useful in non-emergency scenarios for tracking equipment, visitors, staff, or other mobile assets. With these extruded 3D floor plans injected into a 4D portal with an accurate geospatial reference, buildings can then be vertically stretched in elevation, independently floor by floor, or remaining logically geo-registered to allow detailed visibility inside each floor space. These geo-registered floor models can be utilized to present any available sensor information, including live camera locations, video feeds, facility equipment status, building alarms, and CBRNE sensors, while also providing the means to visually select and control these same sensors and equipment. The fourDscape browser provides the user with the capability to maneuver visually through the individual floors, while the real-time tracking reports are dynamically located on the proper floor and in the proper locations. Time-based history tracks for mobile sensors are also maintained. With the fourDscape browser's capability to control the time aspect of the visual scene, archived time-based sensor data can be replayed under user control, time correlated with all other visual scene elements, including multiple sensor data streams. Communicating with sensor devices can be customized for any message format and transport medium, accessed through the geolocated sensor indicators in the fourDscape graphical user interface. The example shown here utilizes a camera management interface to add video analysis rules to a video feed. Timestamped events are received from the camera sensor based on those specific video rules. Event information can be inspected visually, and all information transfers to and from the camera sensor are delivered in standard XML formats. This type of rule-based scenario definition can also be applied to user-defined standard operating procedures and automated system responses. Sensors and subsystems can be controlled directly from the common operating picture. For example, this sample pan-tilt-zoom camera control can be included as an overlay on the video frames, which can transmit controls to the camera system in the required format. This control can be utilized to automatically command a camera to direct its field of view towards the known geoposition of another sensor or alarm. Events and alarms are logged and can be configured to overlay directly in the visual scene, automatically identifying the sensor or alarm location. fourDscape can also provide a comprehensive system activity recording capability, utilizing its embedded SQLite database system to store and report this information. Sensor Analytics can provide additional geolocated identification and tracking of things like moving vehicles and persons, or chemical detections and plumes. In the example seen here, all moving objects in the camera's view are identified and reported back to the command and control system, both as an integrated camera frame and a detailed XML report that can be directly referenced to the camera location. Sensor detections and object motion reports can be visually integrated geospatially into the common operating picture's virtual scene. This example of track filtering displays individual vehicles moving along local roadways and specific groups being highlighted based on selected parameters. This technique can be utilized to visually track specific groups of people through buildings using RFID tags. System alerts can control the virtual scene by zooming into alarm locations, accepting user annotations, and then sharing this data with emergency responders. The emergency data exchange language and common alerting protocol standards can be implemented for all external system communications. EDXL and CAP are XML-based protocols. The fourDscape graphical interface can customize external XML data streams to comply with this specific EDXL and CAP message syntax. fourDscape technology is currently being utilized as the basis of a comprehensive interactive training module for airport ground operations, shown here at an international airport. Its four-dimensional virtual methods are ideal for such dual use as a real-time command and control solution and a virtual training system all in one. Standard operating procedures and training manual pages can be visually integrated within the virtual scene, georeferenced at the appropriate location to produce a visual walkthrough of training materials. These materials can include embedded text, pictures, or video for a multimedia experience. The fourDscape dynamic scripting engine can be configured via XML to process time and event-based scripted actions for embedded training and tabletop training exercises. for both external campus environments and building interiors. fourDscape's design is based on real-time simulation technology, so it is inherently capable of generating an interactive common operating picture from real sensors and assets, or a simulated virtual scene for embedded training, utilizing simulated modules for each subsystem component. For confined geographic areas such as building campuses, airports, marine ports, or citywide infrastructure, our expert technology team can integrate, deploy, and support a 21st century command and control system, bringing innovative and powerful DHS-sponsored technology to implement a unique and effective command and control solution. This command and control solution is based on patented fourDscape software from Balfour Technologies. fourDscape provides a unique and interactive uncommon operating picture, creating automated situation awareness from high-resolution imagery, realistic 3D building models, extruded CAD floor plans, and large suites of deployed surveillance sensors, including HVAC systems, video management systems, various access control systems, and tracking devices, all georeferenced visually in an interactive desktop browser.